right? So for means, we have two. We have Z and T, okay, for means, right? We learned about that in confidence intervals. Why is Z? Why is T? When do we have one over the other? What is T, right? We learned all about that stuff. I took out, if you want to know about T, look in your chapter 8 notes, because we learned all about what T was, how to find T, or what is T, what do we use T, why do we use T instead of Z, all of that good stuff, right? So I'm not going to repeat that because it's in your notes, and we were talking about it, okay? So remember, T is when the population standard deviation is not given. Z is when it is, for means. Proportions is always Z, okay? This is a exactly copy of, wait, let me take a roll real quick before I forget. Okay, so this is exactly the same as proportions tests. Why do we use hypothesis tests? It's when we want to check a claim to see if it's the claim is true. Is what the observed change? The observed change is the claim. Okay, is the claim, is what we find so far away from the claim that it can't be true? Okay, so that's when we test the claim. Same steps, 7 steps. We have a new test statistic. So number 4 is just new. It's not a new step. Conditions, assumptions. Condition 3 is a little different. Hypothesis, we still have null and alternative. Significance level is the same. Number 1, identify population parameter. It starts true mean, right? Conclusions the same. Conclusion, we use the same sentence frame. Calculations are the same, different test statistic, but we use the same type of step. Oh, I did put it in here. No, I didn't. You guys don't have those. Is this the next slide you guys have? Okay, good. This is the notes I was going to give to you guys, but then I realized you guys already have this. You have this. You have it goes into why we use T. What is T? You guys have that in your chapter 8 notes, so I didn't want to include it again. Okay. Okay, so we have 2 different test statistics. If it's T, we use this test statistic over here. It's a z-score. We're trying to find z-scores. So it's a z-score test statistic. Okay, that's for T. If it's Z, we use this guy here. Almost all of the tests that we do in this chapter will be T. Very rarely will it be Z. Just telling you right now. Okay. Yep. All right. Assumptions. These are exactly the same as chapter 8 for means. These assumptions are exactly the same as chapter 8 means. No difference. Okay. The only one that's different than proportions is number 3. And so we have, they tell us in the prompt that the population is roughly normal. They didn't, but our sample size is big enough. Or our sample size isn't big enough. They didn't tell us anything in the prompt, but we checked the graph and really there were no outliers. Outliers are really the thing that will make it very strongly skewed. Okay, that's the big focus there. Okay, hypothesis. Same idea, now we're doing the other side. We did the p's, now we're not doing p's anymore. We're doing mu's, the Greek letter mu for mean. We have 3 options with alternative, less than, greater than, not equal to. Same as always. Okay. Significance level, exactly the same. Nothing to add to that. We either reject or fail to reject. We never accept. Right? Conclusion's exactly the same. The sentence frame is exactly the same. Okay. We're going to find out what's different here in about a minute when we start doing some problems. Okay. Interpreting the p-value, that's the same. Okay, so here we go. Let's look at a problem. Example number 1. Okay, read the problem to yourself, highlight, underline. Okay, so what's one thing that's important before we start the test? N equals 10. Yep, there are 10 AP teachers, so N equals 10. Good. Yep, they tell us the population is approximately normal. That's going to be important when we do our conditions. That the mean is 100. Yep. So this mean here, it says mean of 100. If I wanted to give that a symbol, which symbol would I give it? Would it be X? Let me know where. Would it be X bar? No. Good. Good. That is important. Definitely important. Do they tell us anything about standard deviation? No. So is it going to be Z or T? T procedures. Good. T model or T procedures. Um, anything else they tell us? What else do they? What's that? So is the null hypothesis? We know what's the null going to be? Let's skip ahead a little bit. What's the null going to be? There you go. Alternative is going to be what? Greater than, less than, not equal to? Yeah, why greater than?
Some students hypothesize that AP teachers have a higher mean IQ.
There you go. So all we're checking is higher, because that's what we're testing. All we're testing is higher. Okay. Anything else? Significance level, a little different than we're used to. It's not 5% now. It's 10%. Okay, so let's go to A. True mean. So we know that number is 100. So that represents the true mean what? Yes. True mean IQ of all adults or adult population. I don't think it said anything like US adults or anything like that. I think it's just all adults, right? Yep. IQ score. You could put IQ score, but IQ is kind of the same thing. Okay. Hypothesis. We said hypothesis. The claim is that it's 100. 100 is the average IQ for a population. If someone has an IQ of 100, that means they're average. Half the population has a higher IQ score, half the population has a lower IQ score. So if you're above 100, you're in the top half. If you're lower than 100, you're in the bottom half. Alternative. We said it's going to be greater than 100. Alpha level, 10% from the question. Okay. All right, assumptions, conditions. Let's see. So we have 3. We always have 3. Assumption or condition number 1, SRS. Number 2, 10%. 3, normality. Okay. So the sample was 10, right? You said N is 10. Does it say how they were gathered? Perfect. Stated. Okay. Number 2, small n is less than 10% of big N. Definitely, yes. I would say definitely. 10 is less than or equal to 10% of big N. Well, the population parameter was IQ scores of all adults. So what would big N be? All adults. Yep. Yep. So I think, yeah, at the very least, it's more than 100. Okay, normality. We have 3 options. given that they told us that the population is roughly normally distributed. They didn't tell us, but our sample size is large enough, or none of them, so we have to graph it and look at the graph to see if there's any outliers. There you go. We're going to go number one. Yep. We're going number one here. So this is what we're going to put. Stated as, what did it say, approximately? Approximately normal? I should probably put population. Population stated as approximately normal. That's the easiest one. But don't just put stated. What is stated? Okay, you can put stated for number one, just don't put it for number three. Okay, you got to be a little more direct with that one, a little more specific with that one. Okay. All right. Next one is test statistic. Test statistic. So we have two different test statistics that we can use. We're not going to use both of them. We're only going to use one of them. So we said this one's T, right? So that means we're not using this one. Remember, we have degrees of freedom since it's T, right? T, we have degrees of freedom, n minus 1. Okay. Calculations. Draw the normal curve. What's the middle of the curve going to be? 100. Good. So we have that Z. T equals X bar. Do we know what X bar is? After we figured it out, right? But we weren't given it, right? So we have to do a little bit of calculations here. So let's go put X bar in our calculator if you haven't already. X bar comes from the data, right? So put the data in L1. And then 1 var stats. And then we'll write all this down too. And then we also need standard deviation as well. Oops. Okay. 1 var stats. Here we go. So I get a mean of 108.3. And I get a standard deviation. We use S because it comes from the sample. 499. Okay. All right. So now I'm going to go down and use those guys now. So 108.3 minus 100. And then 4 point, or was it? Standard deviation 9.499. Divided by the square root of n, which is 10. Which way do we shade, right or left?
Right.
Greater than, good. What's degrees of freedom on this one?
9.
9, yeah. N minus 1, so degrees of freedom is 9.
Oh, you need to write that.
I do. Even if I don't use a table, it's good to know. Okay, you can from here, like I said, from here you can go to the calculator and go stat calc. Let's do that right now. Yeah, so we're gonna have a different test today, right? So we go to test. Now the first 2 are tests. The first 6 say tests, and I think that's it, right? Everything else is an interval after that. Yeah, yeah, those that we'll use later in the year. So the first 6 are the only tests. Okay, 3 and 4 we're definitely not using because it's 2 sample. We're only doing 1 sample. We have 1 sample of 10, right? We don't have 2 samples of 10. 5 and 6 are proportions and 2 sample, so 5 and 6 are gone. So the only one we have left are 1 and 2. So which one is best used for this one? 2. What's the difference between data and stats? Yep. Data means I have the numbers somewhere in L1, L2, L3, somewhere. I have all of the numbers. If you do have the numbers, always use that one. Stats is I don't have the actual numbers, but I know what the mean was. I know what the standard deviation is. I know statistics about it. Okay. So data. The claim is 100. I have all my numbers in L1. Frequency, don't mess with, it's just 1. That means each of the numbers, frequency means each of the numbers in my list are only appear once, right? If I put 2 there, that means I would have double. I would have like 2 people with 106, 2 people with 114, 2 people with 121. I don't. I only have 1 of each. That's what frequency means. Okay, and then we chose greater than. From here, preference. If you want to see a nice picture, go to draw. If you just want to see the numbers, go to calculate. I'll go to calculate because there's something on here that, wait, no, never mind. I'll go to calculate. So the T score was 2.763. You can put 6.3 or you can just put 6. Usually for your T and Z scores, we only go 2 places, but if you went 3, it's okay. P-value. This one has a p-value of 0.0110. So were you going to reject this or fail to reject? Reject because, there you go. Yep, that's about 1%. Our p-value here is about 1%. The significance level is 10%, so that would be less. Okay, conclusion. Conclusion needs to have 3 things. 2 sentences, 3 things, whatever. If you want to do different sentences for each, you can, but it has to cover 3 things. So the first thing is p-value versus significance level. So since p-value 0.0110 is less than alpha level, which was 10%, we reject the null hypothesis. We reject the null hypothesis. Okay. Since we reject therefore, we have significant or sufficient evidence to suggest that the alternative hypothesis in context. So let's go back to the alternative hypothesis. Our alternative hypothesis was that this is actually bigger than 100. So what does this represent? The true IQ of AP teachers is greater than, because the sample comes from just AP teachers, right? The sample only comes from AP teachers, doesn't come from the general population. It comes from just AP teachers. So we're comparing those to the population to suggest that the IQ scores, the mean, I should say true mean, AP teachers is greater than 100. All right. So it's pretty standard with, since you guys have already done confidence intervals for means and you've already done hypothesis tests for proportions, it's not much new. There's not much new. Okay. So what I want you to do now is do the second example. I'm going to give you about 10 minutes. Do the second example, 10, 15 minutes. And make sure afterwards you do all of it, because there's 3 questions here, not just one. The last one just had 1. Do the test. This one has 3 parts to it. First question, I have a question. How do we know we need to do a test? If it doesn't say do a test, or if it doesn't say a confidence, significance level. Watch, because there's no significance level anywhere here, right? And it doesn't, I don't see the word test anywhere here. How do we know we need to do a test? What are the giveaways for test? There you go, right there. Does the evidence give convincing reason? Convincing evidence. Something like convincing evidence. Is there convincing evidence? Test. That's code for test. Okay? All right, I'll let you guys work. Okay, so classic rock radio station claims that they play an average of 50 minutes of music every hour. So 10 minutes of commercials, 50 minutes of music every hour. That's their claim. To investigate the station's claim, you randomly select 12 different hours during the next week. So randomly you pick 12 different times where you listen for an hour and record how much music they play. Okay? So like for example, the first hour that you randomly pick, they played 48 minutes of music, then 49 minutes of music, and so on and so forth. Okay? Here is the music in minutes that was played each of those hours. Does this give convincing evidence to question the radio station's claim? Okay, so does this give evidence? We talked about that. That's your key right there to say it's a test. So why is this going to be means? Why is it means? We know it's going to be means because it's part of the means notes, but why is it means? What tells us it's going to be a means? Yeah, you see average of 50 minutes, right? It's not the proportion of minutes, it's actual minutes, right? So that gives us means. Is it going to be a T or a Z? T? Good. T model. We know n is 12. I don't know what x bar is, but I'm going to need that eventually, right? So x bar is the mean of all of those guys. Let me put those guys in my L1. 48, 49, 50. 51, 49, 51. Oops. 49, 47, 47. 50, 46, and 48. Okay, so my mean is 48.916. 48.916. Standard deviation of 1.847. Oops. Okay. Okay, so let me go through the steps that you guys just did.
And you wrote down the standard deviation.
What?
You wrote down your calculation standard deviation.
Let's see. Let me try that one more time.
You wrote down standard deviation of that class.
Oh, yep, you're right. I wrote the wrong one down. 1.9209. Okay. Okay. Okay, so population parameter. Mu equals true mean. What do you guys write?
True mean minutes of music played every hour.
There you go. True mean minutes of music played every hour at this station. So we only looked at this station, right? Okay. So the next one, hypothesis. We have their claim is 50 minutes. What are we going to put for ours? Is it greater than, less than, not equal to? Not. Yeah, not 50. Not 50 because it doesn't say. It just says to question. All it says is to question. Doesn't say higher or lower. Okay. Oops. Significance level. They don't say it, so we use our default, which is 5%. Okay. Or we can go test statistic. So it's a t. So it's x bar minus the claim over standard deviation over square root. Okay. Let's move these up a little bit so I have more room. Okay. Conditions. Check. SRS stated 10%. let's see. So n is less than 10% of big N. Little n is 12. Was it 12 or was it 10? 12. Okay. 10% of, okay, so what is big N? All hours. All hours of music played. Yeah, all hours. You can just put all hours. Okay. Let's see, normality. So this one, nope, they don't tell us it's normal. Our number is less than 30. So that means we are going to have to check for outliers. Okay. So since you have your data already in L1, or hopefully by now, if you didn't, you already did. You did that later on. So we're going to go check to see if there's any outliers. So we're going to use the box plot with outliers. And then go zoom, zoom stat. There's a little skewness, right? There's some skewness. The whisker at the end is longer than the other whisker at the other end, and then inside the box, one side is a little bit longer than the other. So there is some skewness. I'm not going to sit here and say it's not, but it's not crazy skewness because there are no outliers, right? So that's what we're going to put. We're going to put a picture of that. We can assume normality. Due to no outliers being present. You always want to talk about outliers. You could say skewness too, but you definitely want to talk about outliers. Say something about assume normality due to there not being any outliers. So yeah, I would say add no outliers is definitely the reason why, but what does it suggest? You know, that kind of thing. Yeah. Give me 1 second. All right. Let's see. What else we got after that? Test statistic calculation.
We might as well take your stuff. You're not coming back on that.
Yeah, take all your stuff. Yeah.
Yeah, you think you can zoom in there? Absolutely. What a chance. You're getting a little bit hard.
Okay, so the mean was 50. What did we get? 49, or what was it? What was our X bar? 48.916 minus 50. And their standard deviation was 1.929.
Yeah. 1.929.
Divided by root 12. So we have 48.916. Which way do we shade? Left. And then what else do I got to do after I shade this? Yep, two-tailed test, right? Two-tailed test. So I got to find the distance. So the distance here is very small. It's like 1.1 something. So go in the other direction, add that to that, so you get 51.108. Okay. Shade in the other direction as well, towards the extremes. So when we crunch the numbers, stat, test, oh, wrong one. Stat t-test data, because we have it in L1. Their claim is 50. L1 is our list. Frequency is 1, not equal to. Calculate. We get a t-score of negative 1.946. And then we get a p-value of 0.0777. 0.0777. Okay. That's both. That's both purples, pinks together. Okay. So if you want to know what one side is, you just divide it by 2. If you want to know. Okay. So are we going to reject or fail to reject? If we were only looking at one side, would we reject or fail to reject? We would reject, yeah. So that's why it's important to know your hypothesis before you do your calculations. So conclusion, since p-value 0.0777 is greater than alpha level, we fail to reject the null hypothesis. Therefore, we lack or we do not have sufficient or significant evidence to show or to suggest or to say that the true mean minutes of music played is not 50 minutes. We can't say that they're wrong. Are they right? We don't know. We don't say that. But we just say we don't have enough information. We don't have enough evidence. We don't not information. We don't have enough evidence to say they're wrong. Okay. Part B says you also did a confidence interval before this. Let's say you did one last chapter, and a 95% confidence interval said that the true mean number of minutes of songs played is 47.961 to 50.14. Does that support what we got in our answer? Yeah, because it's 50 is within, right? Why? Because 50 is just inside the, because 50 minutes is inside the interval. Yep, very on the high side, very lucky, but still it's in. So it does support that claim. The last thing, can we generalize this? Can we say this conclusion for throughout the whole year? The answer is no. Why not? And those 12 hours only come from 1 week. They only come from 1 week. So if we picked 12 from throughout the year, absolutely. But those 12 only come from 1 week. So we can only say this about that 1 week. If we want to say it more, then we would have to pick like one a month or whatever to do that. Okay. And that's it.